Hey guys, we're going to continue with 6-4 notes. So now you can see that we're going to be talking about exponential decay. And the only thing different about decay is instead of adding the rate, you subtract the rate. But before we get into that, we're going to look at how to see if it is growth or decay or neither. So this is a real straightforward concept that everyone should know by now. Remember, if it's exponential, you're going to have a common ratio. So what that means is you're going to have a constant multiplier. 270 times what is 90? 90 times what is 30? 30 times what is 10? And I kept saying, we talked about in class, take any y divided by the y before it to find the multiplier. So I would take 90 divided by 270. I would take 30 divided by 90. I would take 10 divided by 30. And as long as all of these are equivalent, then you would have a constant multiplier. And I have to actually divide to see what that multiplier is. So when I reduce it, they all reduce down to 1/3. What that means is 270 times 1/3 is 90. 90 times 1/3 is 30. 30 times 1/3 is 10. So we have a constant multiplier. And you can tell that we are going down in value. So we have an exponential decay function. It's exponential because we have a constant multiplier and the y's are decreasing. So this one would be exponential decay. Now let's look here. We need to find our constant multiplier. So you take any y divided by the y before it. And you check to make sure they're all the same. Yep. They're all equal to 2. Now I know most of you guys could probably look at this and go, oh, look, it's times 2. Yes, when it's obvious, it's easy. But over here, it wasn't as obvious. So make sure you pay attention to how we find the multiplier here. Don't just think times 2, it's obvious. 10 divided by 5 is 2. 20 divided by 10 is 2. 40 divided by 20 is 2. And then it will reinforce the concepts when it's not so easy. But now that we have our constant multiplier, we now say, okay, we are exponential and we are growing. So this one would have been exponential growth. Okay? So that's all you're looking for. And if the numbers are not the same, then you're neither. So that should really be enough for example 2, just on how to tell whether it's growth or decay. So first, just make sure it's exponential, which is finding the constant multiplier. And then just look, if you're growing, it's exponential growth. If you're shrinking, it's exponential decay. And now we are looking at it. Is it going to be growth or exponential decay? So remember, we always have our function y equals a times b to the x. And when it's growth, it's y equals a outside of 1 plus the rate to the t, which is x, just the time. If it's decay, it's y equals a outside of 1 minus r to the t. So in general, once I actually take 1 plus r or 1 minus r, that's when we get back to our original form. So these are just the forms we use when someone tells you what the rate is. Then you say if it's exponential growth, you add the rate. If it's exponential decay, you subtract the rate. So we can use that if someone gives us a model. So here we have a function model. Y equals 5 times 1.07 to the t. Now, I don't know what this is trying to represent, but I do know that this has to be growth because I look here. This is my multiplier. I don't care how many I'm starting out with. 5, 10, 20, 50, 2.1, whatever. I start out with a certain amount. That's irrelevant to whether I'm growing or not. Growth has to do with the multiplier. If the multiplier is bigger than 1, or in other words, you add a rate, you are growth. If you subtract a rate, then you are decay. So I look here, I know I am exponential growth. How do I know that? Because my multiplier is greater than 1. Now, to identify the rate of change, how much more than 1 are you? In other words, what would the r have to be to make this number? So this is 0.07 bigger than 1. So we have a 7% growth rate. Okay, so again, look at the multiplier. If it's bigger than 1, it's growth. How much bigger than 1? That is your growth rate. That's how much you're growing by every single round. Now, decay rate. I look right here. Here's my multiplier. Again, I don't care what A is, I care what B is, the multiplier. This is less than 1. That means I'm shrinking. So, is it growth or decay? It's going to be exponential decay, but how much am I decaying? Well, I'm 2% less than 100, or 0.02 less than 1. So, my decay rate is 2%. What you want to do is look at these numbers. 1 is 100%. That's how much you started with. You started with this much, which is 100%. You're left with this much. If it's bigger than 1, then you grew, and however much bigger than 1 is what you grew by. If you're smaller than 1, then you were shrinking, and however much smaller than 1 is what you are shrinking by. Okay? So that should be enough to help get you through exponential growth. And remember, you can always look to the book, but that's all it is. All they're saying is, what is your rate? What are you growing by, or what are you shrinking by? And I'm just going to continue on. Actually, example 5, you can look in the book for. It's just applying. We talked about it in class. It's just applying compound interest. Table 6 is one that's a little bit tougher. So I'm going to go over example 6. The table shows the balance of money market account over time. Write a function that represents the balance after T years. So all we have to fill in, y equals a times b to the x. Remember, a is your y-intercept. Well, y-intercept is when t is 0. So we know we already found a. Okay, so a equals 100. Now all I have to do is find b. Remember, you can always find your multiplier by dividing any y by the one before it. So you can pick any of these. I'm just going to pick the first two. So you would take 110 divided by 100. That ends up equaling 1.1. And you'll notice you divide any of these, you end up with 1.1. So now we can fill out our entire equation. Our final amount is what we started with times 1.1 to the t. In other words, your account is growing 10% every year. You can see it here. 10% of 100 is 10, so 100 plus 10 is 110. 10% of $110 is 11, so 110 plus your 11 is 121. And you keep going. 10% of 121 is $12.10. 121 plus $12.10, $133.10. You can keep following your pattern all the way down. Now, they just ask, what is the balance 10 years if you let the money grow? Hopefully this part is getting easy because in class we were doing this really well. Y equals 100 outside of 1.1. And all they did was they gave us a time of 10. So that goes in there for t. And then I will leave that for you guys to do on your calculator. I don't think that is anything beyond anyone right now. And that will conclude this section. If you have any more questions on this, please feel free to send in on email and I will get you guys caught up. But other than that, thank you very much.